Welcome to this video. Dear children, you read about division in previous classes. So today, in this video, let's see how division is related to Euclid's division lemma. We have 59 chocolates and 3 boxes. We have to keep equal number of chocolates in all the 3 boxes. Can you keep an equal number of chocolates in these boxes? Well done! We saw that 19 chocolates are kept in each box, whereas 2 chocolates remain. Just think, now can you solve it with simple division method? Absolutely right. On solving, we get quotient equals to 19 and remainder 2, where 3 is divisor and 59 is dividend. Now if you want to keep the same chocolates in 5 boxes instead of 3, such that there are equal number of chocolates in each box, then what will you do? Well done! Now we have 11 chocolates in each box, while 4 chocolates still remain, which we represent in this way. Similarly, if the number of boxes is increased to 7, we see that each box contains 8 chocolates, while 3 chocolates remain, which we represent like this. In the above 3 situations, we saw that both dividend and divisor are positive integers. Where on dividing the dividend 59 by divisor 3, 5, 7, we got 2, 4, and 3 respectively. On observing carefully, we get to know that in all the 3 situations, the remainder is less than the divisor, where we represent dividend by A, divisor by B, quotient by Q, and remainder by R. In the above situations, 2 positive integers A and B are seen, where A is greater than B. And there exists unique integers Q and R. On division, we get remainder R, which is greater than or equal to 0 and less than B, from which we can say that A is equal to B times Q plus R. This is known as Euclid's division lemma. Today in this video, we studied the Euclid's division lemma. In the next video, we will learn to find the HCF using this. Welcome to this video. In our previous video, we studied the Euclid's division lemma. Today, in this video, we will learn to find the HCF using Euclid's division lemma. The number of chocolates P and chocolate Q are 1215 and 891 respectively. What is the maximum number of chocolates that can be kept in a box, and how many minimum boxes are required to keep equal number of each chocolate? you can also solve this by hit and trial method. But here we will solve this in a stepwise manner, for which we will find the HCF, that is, highest common factor of the number of both types of chocolates. For this, we will use Euclid's division lemma A equals to B multiplied by Q plus R. Let's try to solve it together. Here, 1215 is greater than 891. Now we will use Euclid's division lemma on these, which gives us this value. Since the remainder is not equal to 0, we apply the Euclid's division lemma again to divisor 891 and remainder 324. And by this, we get this value. Here also, the remainder is not equal to 0, so we apply the Euclid's division lemma once again. The remainder has now become 0, so our procedure stops here. Since the divisor at this stage is 81, which is the HCF of 1215 and 891, so maximum 81 chocolates can be kept in the box out of chocolate P and chocolate Q. Since we have to find the minimum number of boxes required, can you tell what we have to do in order to find this? Well done! If we divide the number of chocolates P and chocolate Q by 81, that is, the maximum number of chocolates that can be kept in a box, and add the quotients obtained, we get 26, which is the minimum number of boxes required. Hence, minimum 26 boxes are required to keep the chocolates. Now, let's understand the difference between Euclid's division lemma and Euclid's division algorithm. Euclid's division lemma is a proven statement which is used to prove another statement, while algorithm is a series of well-defined steps which is used to find the HCF of two positive integers a and b, where we can use the statement a equals to b multiplied by q plus r of Euclid's division lemma. Today in this video, we saw an example based on Euclid's division lemma. In the next video, we will see the common errors which occur while solving these types of questions. Welcome to this video. In the previous video, we saw an example based on Euclid's division lemma. Now we will see the common errors which occur while solving these types of questions. Example 1. A shopkeeper has 1,517 pairs of shoes and 902 pairs of slippers. He wants to keep them in boxes in such a way that the number of pairs of each type of footwear remains equal. How many pairs can be put in each box to do this? Pause the video to solve the question and then match your answer. Since here we have to find out the equal number of pairs of both type of footwear that can be kept in the box, so we have to find out the HCF of both, and for this we use Euclid's division lemma. Here 1517 is greater than 902, So we substitute the value of A and B and solve. If you have selected option 1, then it's a good try. But it's a wrong answer. As while using Euclid's division lemma, you hastily select dividend in place of divisor, because of which your answer gets wrong. Here, to find HCF, we used Euclid's division algorithm, which is based on Euclid's division lemma. If you have chosen option 2, then it's a good try. But this is also a wrong answer, because when you apply Euclid's division lemma again to the new divisor 902 and 615, then you get negative remainder, which is not correct, as in the lemma. Value of r is not negative. It is either greater than or equal to 0. And in this procedure, we don't get 0 as the remainder value. This we also ignore. And for this reason, here, you consider 615 as the HCF of 1517 and 902. Hence, your answer becomes wrong. If you have chosen the third option, then it's correct. To find the HCF, let's solve this using Euclid's division lemma. Here, 1517 is greater than 902. We repeat the process of Euclid's division lemma until the remainder is 0. Here we get remainder 0. So the process ends here. Since the divisor at this stage is 41, so the HCF of 1517 and 902 is 41. So the option 3 is correct. Hope you must have understood why the third option in this example is correct and the rest all are incorrect. Teachers can also check the understanding of the students in the class with the help of such examples.